All right, ladies and gentlemen, let's go over these items for the final. First topic there is IR spectroscopy. Basic knowledge of how IR spectroscopy works. In the sense there, I'm asking you what happens to a molecule when you put infrared radiation into it. What I'm looking for there is a discussion of the bending and the stretching of the bonds. Uh, in in the case of UV spectroscopy, there on number two, then it would be the excitation of pi electrons, usually in conjugated systems. So that's what's going on there is in both of those cases. Um, Remember that when we're looking at IR spectroscopy, our purpose is we were looking for functional groups. We did not use it for like quantitative things. So our main goal was to look for patterns in functional groups. Be familiar where the fingerprint region is. If you remember that, typically we said it was anywhere from probably about 1200 down. Um, and then major IR bands, you have your sheets, the listings of them. So make sure you know what different kinds of bands do at different parts of the spectrum. How to prepare your samples. We had two different methods. The solid we put onto the diamond uh, device, and in our liquids, obviously, we had to have these salt plates, and we had to put our material between the salt plates in order to take our readings. On UV spectroscopy, if you'll remember, um, we said that the as you get more, as you extend the conjugation of the system, you get absorption at longer and longer wavelengths. And if you get enough, obviously you can make the molecule actually absorb in the visible region of the spectrum. And when we had to prepare our samples, if you'll remember on this, I don't have that on your sheet. I'll stick it on here. Um, the preparation of the sample. You'll remember that we had to take a microliter of the material and then dilute it in 50 milliliters of solvent. So in that case, that kind of takes care of both of those topics. So there'll be, some spectra that you'll have to look at and answer some questions about them. Obviously, I might just throw out a number and ask you what that means as opposed to giving you a spectrum. If I said something like a peak at 3,400 would probably be indicative of what type of a what type of a compound, and then I might mix that in with when we talk about a little bit later down here um, in the hydrocarbon, or in not in the hydrocarbon, but in the functional groups lab. I might mix results from a spectrum with, some tests that you did. Like, oh, I did a DNPH test and got a positive result. And also, uh, I saw a peak at 1714. What might that mean? So, I might combine two of those things together to get something to you to elicit a response based upon that. Um, on the techniques, micro boiling point, how does the method work? When should you take the readings? And remember, it's a range of readings. Remember, you would look for rapid bubbles, and then the rapid bubbles would slow down, and then you would have the slow bubbling. Once you saw the slow bubbling happening, uh, then you knew that you needed to turn off the device, wait for the liquid to be sucked up into the tube, and at that point you take a temperature reading, and then as you heat it back up, when the first bubble leaves again, then that will be the top of your melting point range. So when the liquid first gets sucked in, bottom of your boiling point range, excuse me, I think I said melting point, and then when the first bubble leaves again, then that would be the top of your range there. And remember, typically on that, you're going to get a little bit, probably bigger range on the boiling point than you will on the melting point. Um, so the melting point method, obviously, you have to put your sample into the tube. You know, we talked a little bit about that, grinding the sample up, getting it into the tube, packing the tube, and then raising the temperature up. And obviously, for melting point, if something's pure, you're looking for about a 2 degree, no more than a 2 degree range in temperature. Um, and then the mixed melting point method, you can determine if something's pure by mixing a known sample of the thing you think you might have with your sample. And if your melting point's in a 2 degree range, then you probably did have something that was fairly pure. I think that kind of covers all that there. So what? Oh, obviously, if you have impurities and you do a mixed melting point, then remember that will lower the melting point of the substance, and it will broaden it. So you'll have a wider range, and it will be lower than the anticipated melting point. And when we say good melting point range for purity, 2 degrees is usually the accepted value there. Refractive index, um, typical typical values. We typically, those are in the 1 point something ranges. And there, you will have to look up in the back of the book, because we did not have to, because the room was at 20 degrees the night we did the experiment. There is an equation of a little multiplying thing that you have to do in order to add on or subtract, depending upon the temperatures above or below 20 degrees. Um, and you'll just have to do a little calculation with that and talk about how much you would have to adjust your reading by. There will be you will see when you hit the screen and you saw the refractive index in there, you'll have to take a reading off of the device. Um, Recrystallization. How do you pick a solvent? What are good properties of a solvent? We want a solvent to be not have a high boiling point. We want it to obviously dissolve your material at hot temperatures, but not dissolve your material at lower temperatures. You don't want it to be uh, I don't know what else I want to say on that one. I think that probably takes care of it. When should you use distillation? You should use that when you've got two substances that typically are about 30 degrees apart in boiling points. And what does it do to an impure compound? Well, it should narrow the boiling point range of a mixture of two materials. Once you distill it, you should get most of the material out, and now your new material should have a much narrower boiling point range. Um, Extraction. Remember that in extraction, you have to have two materials that don't dissolve in each other, so that you can have two layers, and then you can remove a chemical from one layer and put it into another layer. And remember some of our common materials. I might ask you which material, based on densities, is on the top or on the bottom in a certain situation. And remember that typically, in a lot of the cases, we had water soluble compounds that you would put a drying agent in there after you got finished. In the organic layer, we mixed some magnesium sulfate or some sodium sulfate in there, so that we would get rid of the water that might be remaining. You remember sometimes those separations weren't perfect. And remember that we did multiple as opposed to one extraction, and we combined our extracted layers. Um, it has been proven over and over and over again that extracting something with smaller portions multiple times is going to be better than doing one extraction. So I'm stop there for the first video, and then you'll go right into the second one.